Welcome to SND College of Engineering and Research Center, Yeola, Department of Applied Science online lecture series. Today's lectures on Engineering Physics, Unit 1st, Wave Optics, and second topic, diffraction. So first we will discuss about what is diffraction. The word diffraction is derived from the Latin word diffractus, which means to break into piece. The phenomenon of bending of light round the corners of an obstacles and resulting into a geometrical shadow is called diffraction. Diffraction is the slight bending of light as it passes around the edge of an object. Spreading or bending of light waves as they pass through an aperture or round the edge of an obstacle to produce a geometrical shadow region containing dark and bright bands is called diffraction. The distribution of light intensity into dark and bright fringes is known as diffraction pattern. There are two types of diffraction: Fraunhofer diffraction and Fresnel diffraction. Fraunhofer diffraction means what? The diffraction in which the distance between source and screen is infinite from the diffracting element is called Fraunhofer diffraction. And Fresnel diffraction means what? The diffraction in which the distance between source and screen is finite from a diffracting element is called Fresnel diffraction. So today we will discuss about Fraunhofer diffraction at a single slit. On screen you have to see one diagram. Our problem is to find intensity of light at point P. Let a parallel beam of light having wavelength lambda incident normally on slit. According to Huygens principle, every point on a slit acts as a secondary source of light and it emits secondary waves. When these secondary rays travel without any deviation and focus at point C on the screen, as these rays have no path difference, point C principal maxima having maximum intensity. When these secondary rays travel with a deviation angle theta, focus at point P and P dash on the screen. Intensity of point P and P dash on the screen depends on the path difference between the first and last secondary rays reaching to the point. So let the slit of width A is divided into n number of parallel infinitesimally small slits, each of width dx. Therefore, A is equal to dx plus dx plus dx plus number of n times. To find the path difference between ray first diffracted from the top edge of the slit and ray 2 diffracted from the bottom edge of the slit is dx sin theta. Therefore, phase difference d phi is equal to 2 pi upon lambda dx sin theta. Total path difference between light rays diffracted from top edge and bottom edge of the slit of width A is A sin theta. Then phase difference phi is equal to 2 pi upon lambda A sin theta. The amplitude of vibration of a wave from each small slit is same and so represented by a small vector known as phasor. There are n phasors of the same amplitude and the same phase difference. The phasor of equal amplitude and same phase difference between adjacent phasor from an arc of a circle. The length of an arc is denoted as r, represented maximum amplitude obtained by adding the phasor without any phase difference between them. To find resultant amplitude, on the screen you can see phasor diagram. R and E theta is the curve distance d phi. So the AC is the chord of a circle and it shows the resultant amplitude. So AB is the chord of a circle and it shows the resultant amplitude E theta. Draw a perpendicular from a apex angle D on the AB. It will bisect the chord as well as apex angle. Angle ACD is phi by 2 and angle BCD is phi by 2. Chord AB is denoted as E theta and AC is the radius is denoted as R. Then chord AB is equal to E theta is equal to amplitude of resultant wave disturbance at point P. Arc AB is equal to EM, maximum possible value of the amplitude. If CD is perpendicular to AB, then AD is equal to BD is equal to E theta upon 2. Angle ACD is equal to angle BCD is equal to phi by 2 is equal to pi upon lambda A sin theta is equal to alpha. Phi by 2 is denoted as alpha says. Then in triangle ADC, sin phi by 2 is equal to AD upon R. Then therefore AD is equal to value of E theta is E theta upon 2. Then value of E theta is R sin phi upon 2. Therefore E theta is equal to 2R sin phi by 2. Now angle is equal to length of an arc upon radius of an arc. Therefore phi is equal to EM upon R. Rearrange this equation. R is equal to EM upon phi. E theta is equal to 2 into EM upon phi sin phi by 2. Therefore E theta is equal to EM upon phi by 2 sin phi by 2. Therefore E theta is equal to EM sin alpha upon alpha. E theta is equal to EM sin alpha upon alpha. Therefore alpha is equal to pi by lambda A sin theta. This is the path difference between. Then condition for principal maximum, E theta is equal to EM sin alpha upon alpha. Then EM alpha, put the values of alpha, alpha minus alpha raised to cube upon 3 factorial plus alpha raised to 5 upon 5 factorial plus alpha raised to 7 factorial and so on. There is equal to EM, get alpha cancel in each term. Therefore 1 minus alpha square upon 3 factorial plus alpha raised to 4 upon 5 factorial minus alpha raised to 6 upon 7 factorial and so on. For maximum possible amplitude, E theta is equal to EM. This will happen when alpha is equal to 0, that is when pi upon lambda A sin theta is equal to 0, that is when sin theta is equal to 0, when theta is equal to 0. Next condition for minima. Minimum intensity means E theta is equal to M sin alpha upon alpha is equal to 0. Between two minima a secondary maximum is present for the condition. And condition for minima is sin alpha is equal to 0 but alpha not equal to 0. Then alpha is equal to plus minus m pi when pi upon lambda A sin theta is equal to plus minus m pi. A sin theta is equal to plus minus m lambda, that is theta is equal to sin inverse plus minus m lambda upon A. Position of first minima. Next, diffraction pattern of a single slit. You can see in 0th the maxima is higher peak and other away from a distance the amplitude is minimum. you can see diffraction pattern. I hope student you have understood this. Thank you.